Hello, historical geology students. This video is going to be called Spring6, and it's for January the 25th to February the 1st. It's another lecture, and last time we were talking about the geologic time scale, and I talked about the eons. And once again, what are the eons? Hadean, 4.6 to 4 billion years ago. Then what? Proterozoic, 4 to 2.5 billion years ago. Then what? Proterozoic, from 2.5 billion years ago to 542 million years ago. Last but not least is what? The eon we're living in, called the Phanerozoic eon. 542 million years ago till now. Got to memorize that. As far as the eras go, there's 3 eras in the Phanerozoic eon. You don't need to know any of the eras for the Hadean, Archean, or the Proterozoic. You only need to know the eras for the Phanerozoic eon. There are 3 eras that you need to know about. We've got the Cenozoic era of the Phanerozoic eon. Then we got the Mesozoic era. And then we got the Paleozoic era. Notice in historical geology, we always put the bottom one, the oldest, on the bottom. In order to memorize those, it's easy if you just memorize what it means in Latin. Paleo means ancient. Meso means middle. And Ceno means recent. Well, what does Zoic mean? It means life. So the Paleozoic era is the era of ancient life. And it began 542 million years ago. And it continued on to 245 million years ago. 245 million years ago, we begin a new era called the Mesozoic era, which began 245 million years ago and ended 65 million years ago. MYA means millions of years ago. I don't know why it should be MYA. Good Lord in heaven. Okay, anyway, it's MYA. And then the Cenozoic era began 65 million years ago, and it continues on till today. So what eon are we living in? We're living in the Phanerozoic eon. What era are we living in? We're living in the Cenozoic era. Okay. Now, the Paleozoic era is the era of ancient life. And it's dominated by the following life forms: fish, amphibians, reptiles, and invertebrates. What are invertebrates? Those are creatures that don't have a backbone, such as snails, clams, worms, octopus. So the Paleozoic era is dominated by fish, amphibians, reptiles, and invertebrates. The Mesozoic era, from 245 to 65 million years ago, is dominated by dinosaurs. The Cenozoic era is dominated by mammals, including humans eventually. Those are the 3 eras you need to know, ladies and gentlemen. Now we want to break these eras down into periods. So for the Paleozoic era, we have the Permian, then the Pennsylvanian, then the Mississippian, Mississippian, then the Devonian, Silurian, Ordovician, and the Cambrian. Remember, the oldest is always on the bottom in historical geology. So what's the last period of the Paleozoic? The Permian. What's the first period of the Paleozoic? The Cambrian. You need to memorize that. Find some way to memorize it. I'll give you 2 rhymes in a moment that you could use. But there's 3 periods of the Mesozoic. And the last period of the Mesozoic is called the Cretaceous. Before the Cretaceous, we have the Jurassic. And the first period of the Mesozoic is called the Triassic. You've got 2 periods for the Cenozoic you need to remember. The Quaternary period and the Triassic period. Somehow you need to memorize this. Quaternary, Tertiary, Cretaceous, Jurassic, Triassic. I hope you're taking good notes, because the test is going to be, you can use your notes on the test. It'll be, so write down, have your notes ready for the test, so write this stuff down. But when you're taking a multiple choice test, and it's an hour long, it's 50 questions, it's hard to go through all your notes, so it's better to memorize some of this. And you could memorize this one here, for example: Permian, Pennsylvania, Mississippian, Devonian, Silurian, Ordovician, and Cambrian, in different ways. But my girlfriend gave me something you can use. She said, "Pretty poppies make Dorothy sleepy. Order coffee." You can do it that way. Just make some kind of rhyme. Periods break down into even smaller units called epochs. Epochs are the smallest division of geologic time. For example, we can divide the Cenozoic era into the following epochs: the Holocene, the Pleistocene, the Pliocene, Miocene, the Oligocene, the Eocene, and the Paleocene. Again, you can make rhymes to figure that out, to memorize this. And so to make a long story short, whatever you want to use. See, I think that, and don't take this bad if you're a Catholic, but I was getting tired of going to confession, and I made this rhyme: how poor papal missionaries ordinarily eat people. And if you're Catholic, don't take that the wrong way, because I asked Father Michael if I could use this in class, and he said Catholics have to have a sense of humor, don't they? Anyway, there's better rhymes that you can come up with than that. Make some. Let's see. Let me think of a better rhyme here. Anyway, I'll give you another rhyme later on, but just try to memorize that in some way. So those are the units of geologic time. We already know what uniformitarianism is. And the last thing we want to talk about in this chapter is climate change, or global warming. Now, I'm not going to come at this from a political perspective, but from a scientific perspective. And I can tell you for sure that temperature worldwide has been increasing since the 1880s. You can see that this rise in global temperature, it's extreme. If you ask old timers in any of the 50 states, they'll tell you it used to be a lot colder when they were young. For example, my home state of New Jersey, back in the 1970s, it was quite common to get a foot of, or maybe 16, 20 inches of snow before Christmas, several days. Now we almost never get snow. If you ask the old timers in Tennessee, you'll tell you it used to be a lot colder in the past overall. What is causing this rise in global temperature? Well, there's two factors involved. There's a natural cycle of global warming. In other words, global temperatures increase and decrease due to a natural cycle that has to do with the way the Earth orbits around the sun. So in other words, over time, the temperatures will naturally go up and go down. But the increase in temperatures, the increase in temperature has been going on. This natural increase in temperature has been going on since 10,700 years ago. 10,700 years ago, the Ice Age ended. And when the Ice Age ended, global temperatures have been rising. So global temperatures have been rising over the last 10,700 years. Now, why are we so concerned about this if it's natural? That's because there's also effect from mankind. We are causing the global temperatures to rise too fast in a dangerous way. And this is something that's very worrisome, because the ice, in which most of the world's fresh water is stored in glaciers and ice, in Antarctica, in Greenland, and in northern Russia and Canada. As this ice melts, global sea level is rising, and so that many of the world's coastal cities are now threatened with flooding. What other things are we worried about? Well, as global temperatures rise, the deserts are starting to grow. And as the deserts grow onto formerly fertile land, people were losing farmland. And in much of the third world, people are hungry because of the growth of the deserts. We're getting more and more hurricanes. We've had more Category 5 hurricanes over the last 15 years than we did over the previous 100 years. And what causes hurricanes? The warming of the oceans. Tropical diseases are moving into temperate areas. Tropical species are moving into temperate areas. For example, fire ants used to only be far down south in South America, and now they've already reached Tennessee. Cold weathered species are becoming extinct or are in danger, such as polar bears. So we have to do something to stop this global warming. And what effects do human beings have in accelerating this global warming? First thing you want to understand is something called the greenhouse effect, and we'll talk about it more later. The greenhouse effect. The more carbon dioxide and methane you have in the atmosphere, the warmer the Earth gets. Why is that? Well, imagine the carbon dioxide and the methane in the atmosphere being like the glass on a greenhouse. When the sun penetrates through the glass and it warms the Earth, and some of this heat rises back, but the CO2 and the methane forces this heat back to the Earth. It keeps this heat close to the Earth. So the more CO2 and methane we have in the atmosphere, the warmer the Earth gets. Since the Industrial Revolution in about 1880, we see a massive rise in global temperature. And that's partially due to burning of fossil fuels. That's oil, natural gas, and coal. The more fossil fuels we burn, the more CO2 there is in the atmosphere. And therefore, the warmer the Earth gets. We've burned trillions of tons of coal and oil and natural gas, leading to temperatures to increase. Now, what removes CO2 out of the atmosphere? What removes CO2 out of the atmosphere is trees. Well, do we have more trees now, or did we have more trees back in George Washington's day? We have more trees back in the 1700s than we have now. We've cut down millions of acres of trees. So at the same time that we're burning fossil fuels, we've been cutting down trees and we're removing less CO2 out of the atmosphere. Trees remove CO2 from the atmosphere for photosynthesis. So we're having a dangerous rise in global temperatures. Therefore, the only logical thing we can do is to plant more trees and to use less fossil fuels. But it's not so simple. What happens is basically based on politics. On the extreme right, politically, you have people who say that global warming and climate change is a hoax. It's not a hoax. Even very conservative scientists know that global warming is occurring. And that on the extreme left, you have people who say we should ban the burning of fossil fuels and use green energy only. We can't do that. If we do that, our economy is going to collapse. So, as in most things, I believe the middle is the right answer. We need to move away from fossil fuels, promote green energy, but we're still going to need fossil fuels until we make that transition, until green energy is more affordable. And we need, therefore, to have an oil industry in this country and a natural gas and some clean coal while we're making this transition. If we don't do that, we just move completely to green energy, our economy will collapse. And if we ban fossil fuel, the mining of fossil fuels, oil, natural gas, and coal in the United States, then we'll be dependent on the Middle East, and our trade deficit will go out of control. Also, if we have oil drilling and natural gas extraction and coal mining in the United States, it produces jobs, high-paying jobs. So I think the middle ground is better. Yes, we should move to green energy, but in this, we have to wean ourselves off it slowly so our economy doesn't collapse, in my opinion. Okay, that's the end of chapter 1, and I wanted to get started a little bit into chapter 2. Chapter 2, Minerals and Rocks. First thing you should know is that a mineral and a rock are two different things. Minerals have 4 characteristics. Minerals always must be naturally occurring. So a diamond made in the laboratory is not a mineral. Mother Nature has to form a mineral. A mineral must be crystalline. That means, let me show you what that means by going here. Let's see. a mineral must make crystals. And crystals look like this. They have faces and points in irregular geometry. So minerals are made of crystals. So glass is not a mineral because it doesn't form faces and points. Glass is not a mineral. It must be solid. Would liquid mercury be a mineral? No, because it's not solid. It has to be solid. And it must have a fixed chemical composition. What's that mean? That means that, for example, there are 3,000 or so minerals known to science. One of them is quartz, Quartz. Quartz is always has a fixed. It's always made of SiO2. Doesn't matter if you find quartz in Indonesia, in Japan, in Russia, the UK, or even in God's country. The land of milk and honey, paradise on earth. Where's that? Guess. Coalfield. No, I'm just kidding. But if you're from Coalfield, I like Coalfield, but it's not all those things. Anyway, so minerals are naturally occurring crystalline solid with a fixed chemical composition. There are 3,000 or so minerals known to science. Some common ones include quartz and feldspars. If you took physical geology, you remember these things. Talc, olivine, etc. We're not going to be talking about all the different minerals. Just know that, because that's physical geology, but just know that there are 3,000 or so minerals naturally occurring crystalline solids with fixed chemical compositions. Rocks are combinations of different minerals. So here's a common rock. And there's 3 kinds of rocks, by the way. 3 kinds of rocks you need to know about. Igneous rocks, metamorphic rocks, and sedimentary rocks. Igneous rocks were at one time molten or liquid. So when you heat up the earth, the rock is going to melt. And when that molten rock cools and crystallizes, it makes an igneous rock. Igneous rocks are born of fire, of heat in the earth. The deeper you go in the earth, the higher the temperatures are. So deep in the earth, you're going to make lots of molten rock. And we have a special name for that, and that's called magma. Magma is liquid rock. Magma will form igneous rocks. But if the magma reaches the surface of the earth, we call that a lava. Metamorphic rocks are rocks that have changed due to one of 3 factors: an increase in pressure in the earth, an increase in temperature in the earth, and or the presence and or hot fluids in the earth. So metamorphic rocks form from an increase in pressure in the earth, an increase in temperature of the earth, and or the presence of chemically active fluids, hot fluids. So metamorphic rocks were once something else, and then if you increase pressure or increase temperature or add chemically active hot fluids to a rock, it could change into something else. So I'll make another video after I eat lunch, so we'll do another video soon.